Hello, and welcome to today's presentation. My name is Brandon Copeland, and I am the Omdena Jordan Chapter lead. Today we'll be discussing our first ever challenge for Omdena entitled Detecting and Mitigating Traffic Accidents Using Machine Learning and Traffic Data. Why did we decide to choose this particular topic? The Hashemite Kingdom of Jordan is a smaller country that has roughly a 5.9 million person population. Despite the low numbers in population, however, traffic accidents remain the second leading cause of death in Jordan. Additionally, according to the Ministry of Transportation, the related costs to traffic accidents here remain in the billions of dinars. In order to put that into perspective, average salaries here are anywhere from 250 to 300 dinars per month. So traffic accident related costs in the billions gives us an idea of how devastating both the toll on human life can be, in addition to the toll on the budget of the country. As you can see from the slide here, the number of accidents grew exponentially throughout the years as more cars started to take the road here in the kingdom. Therefore, we decided to put our skills to use in order to be able to find a way that we can help mitigate some of the accidents that happen here in the kingdom. To that end, we reached out to the Civil Engineering Office of the University of Jordan in connection with the Ministry of Transportation. We successfully secured 3 separate data sets with traffic data from the kingdom, or throughout the kingdom, from the years of 2021 onwards. From that data, we were able to pull out information including accident IDs, locations, timestamps, as well as various other pieces of information that were helpful in allowing us the opportunity to be able to analyze this data and try and come up with ways that we can help mitigate some of the traffic accidents happening here in the kingdom. Additionally, we took it upon ourselves to web scrape data related to weather conditions, since that information was not always included inside of the data sets, in order to try and pair weather conditions with the numbers of related accidents to find whether or not there was a correlation between the two. And of course, there was to a degree. So how do we put this information together? First and foremost, the data sets that we provided, given that the University of Jordan, as well as the Ministry of Transportation, provides information in the Arabic language, we had to first and foremost translate this information into English. In order to do this, we had a dedicated team of collaborators who were both English and Arabic speakers who used a combination of Python and the Google Translate API to take the information inside the data sets and to translate those from Arabic into English. Thereafter, we were able to take some of the data, as a matter of fact, all of the data, and check for quality and pre-process the data so that we can prepare it for modeling. We used a combination of cluster analysis with the scikit-learn library. As mentioned previously, we were also able to web scrape data and put that all together inside of a GitHub repository with all of our findings. As you can see from the illustration, we were able to cluster information regarding the high incident areas with respect to traffic data. We entitled these hotspots. And these hotspots, we were able to try and detect patterns of frequency where these accidents were happening, and things such as road design, the flow of traffic, as well as weather conditions, in order to be able to plot some of these hotspots. We found that actually road design and some of the weather conditions were highly factored into the numbers of traffic accidents. Additionally, within the city of Amman at least, which is built between 7 various mountains, we found that the terrain was extremely difficult to handle, especially during the winter months, with respect to accidents because of the fact that there are a lot of inclines and a lot of poor road design that would sometimes lead to high numbers of traffic accidents. We learned a great deal throughout this challenge, being that this was our first challenge. However, there were two things that really stood out to the collaborators, and that was the importance of quality data. Despite the fact that we were able to secure this data from the ministry, we still found that the data set was lacking information, and there was a lot of ambiguity with respect to some of the symbols and acronyms that were mentioned inside of the data sets. Upon request of further information and clarification, oftentimes that information was not as forthcoming as we wanted it to be. So what we decided to do is make the best use of what we had and to pair that with web scrape data in order to come up with some of our conclusions and our results. Therefore, we learned that quality data is the lifeblood of any project, and we certainly learned that the hard way throughout the challenge. The second issue that stood out was the importance of stakeholder engagement. As mentioned, we would have liked to have received a bit more engagement on behalf of our stakeholders. That was not always as forthcoming as we wanted it to be. And we understand that when dealing with ministries and official offices that represent these ministries, that sometimes it can be a bit lengthy with respect to requests for additional information, because it has to go through so many channels in order to be provided, and we respect that. And obviously that happened in certain situations and scenarios where we wanted to receive additional information. However, it just would have taken too much time in order for us to be provided said information. So we made the best of the situation. However, we did learn that having engaged stakeholders that are ready and willing to help at any moment is certainly one of the most important parts of any project. Finally, I would like to thank our collaborators who, without their hard work and investing their time into this project, this would not have been made possible. To that end, we've also produced a 24-page report that we will be sharing with Omdena for those who are interested in seeing all of our exploratory data analysis, as well as some of our recommendations on how these traffic accidents can be mitigated. We would like to thank Omdena, our collaborators, our stakeholders, and everybody who played such an integral part in this project. And we certainly hope to have more projects in the future such as these, and to be able to use our skills and qualifications to give back to society. Thank you so much for your time, and thank you for listening.